Greetings everyone. 3. Be seated in your groups. 2. Get writing utensils. 1. Turn your focus to today's agenda activity.
Greetings, Miss Hope.
Have any of you heard of the term Pythagorean theorem before?
Yeah, we used it a lot last semester when we worked with triangles.
That is right. Pythagorean theorem is a fundamental relation in Euclidean geometry among the three sides of a right triangle. In short form, the equation reads a squared plus b squared equals c squared. A right angle is formed when two lines are perpendicular, locate a point on each, and connect them. You would have connected three non-collinear lines, creating a right triangle. Today's discussion provides a guide that explains the relationship among the three sides of the right triangle. Using Geometer's Sketchpad as our research tool, discuss at your table.
We decided to mount squares on each side of the right triangle. We labeled their sides and using area formula of a square, we calculated the area of each square. Thus, since we have three equations for three squares and three unknowns, we can easily use algebra to get the exact measure of each side length of the right triangle.
Very well, that is a valid explanation of the Pythagorean theorem. Who is next?
We started with 4 copies of the same right triangle, using transformations. 3 of these were rotated 90, 180, and 270 degrees, respectively. Each has area, A times B, divided by 2. We put them together without additional rotation so that they formed a square with side C. The square has a hole with the side A minus B, summing up its area, A minus B divided by 2, and 2 times A times B. The area of the 4 triangles is 4 times area of one triangle. Area of the big square equals the area of the middle square plus area of the 4 identical right triangles. Through algebra simplification we arrived at the Pythagorean formula.
Good job, that is a well thought out proof. Who is next?
Our approach starts with the same 4 triangles, except that, this time, they combine to form a square with a side, A, plus B, and a hole with the side C. We can compute the area of the big square in 2 ways shown on the whiteboard. Thus, A plus B squared equals 4 times A times B, divided by 2, plus C squared. We find that through algebra, we can derive the Pythagorean theorem.
Well done, that is a valid proof. In conclusion, given a right triangle, A squared plus B squared equals C squared is possible because of the proportional relationships of sides and angles of a right triangle. The theorem is reversible.
What does this mean?
It means that a triangle whose sides satisfy A squared plus B squared equals C squared is right-angled. This theorem is the cornerstone and backbone of trigonometry and is used to calculate distance between 2 points.
What if we do not have a right triangle?
The key characteristic of the triangle is to make sure it is a right triangle before proceeding to relate its side lengths by the Pythagorean identity. Students, remember that Pythagorean's theorem allows one to calculate the distance between 2 points. We just learned about this in 2D space. In more advanced lessons, you do it in 3D space and applications such as in the field of computer science. Other studies also make use of this fundamental identity. In your folders, you will find that problem set for this lesson. Go ahead and open your copies and begin to work at your stations. I will come around to check on your progress and address any misconceptions. What is not completed in class shall be your homework till we meet again. This is the Works Cited page for this activity.